JANUAR.
Over the past 3 lessons, we've taken a close look at how the 3 most fundamental quantities in science, length, time, and mass, are defined. In this lesson, we'll explore 4 other fundamental quantities: electric current, temperature, amount of substance, and luminous intensity. Now let's begin with electric current. The word current means that something is flowing. But what exactly is it that's flowing? From our previous lessons, we already know that a hydrogen atom is the simplest atom, consisting of just 1 proton and 1 electron. The proton is positively charged and the electron negatively charged. These charges underlie the electromagnetic force and electric current. That's right. Electric current is simply the flow of electric charge. In other words, it refers to the movement of positive or negative charges. If electricity is based on charge, why is the fundamental quantity defined as electric current, the flow of charge, instead of charge itself? To use charge as the standard, we would need to isolate a single charge and reproduce its value repeatedly. But the technology simply didn't exist at the time. By contrast, an electric current produces forces and magnetic fields, and these effects could be measured precisely and reproducibly even at the time. In the end, the standard had to be based on what could be measured accurately. That's why it was defined in terms of electric current rather than charge. But here's an interesting question. What do positive and negative actually mean in electricity? And who first introduced these terms? Humans have long known about lightning and static electricity. But with the invention of the Voltaic pile in 1800, electricity began to be used in earnest. Around 1750, Benjamin Franklin believed that electricity was a kind of fluid. He thought it flowed from places where there was more to places where there was less. In other words, if some flowing substance caused electrical phenomena, he defined places with more of it as positive and places with less as negative. According to this view, electric current flowed from the positive terminal, where there was more electrical fluid, to the negative terminal, where there was less. In reality, electrons flow from the negative terminal to the positive terminal. However, for various historical reasons, the original convention has remained in use. The main reason is that many fundamental laws of electricity had already been established before the true nature of electric current was understood. The important point is that positive and a negative are just labels. They are names humans assign to distinguish between 2 opposite kinds of charge. But as science and technology advanced, the conditions needed to define a standard based on electric charge gradually began to emerge. With the discovery of the electron, scientists also confirmed experimentally that every electron carries exactly the same amount of charge. This made it possible to reproduce a single unit of charge reliably and use it as a standard, paving the way for a new definition of electric current. The amount of charge carried by a single electron or proton is a fixed value. This fundamental constant is called the elementary charge. The charge carried by a single electron is called the elementary charge. It is a fundamental constant of nature with the same value everywhere and at all times. The elementary charge is approximately 1.602 times 10 to the minus 19th coulombs. The ampere is now defined based on this value. The number itself isn't important. Just focus on the concept. 1 ampere is defined by the number of elementary charges passing in 1 second. If about 6.2415 times 10 to the 8th elementary charges pass in 1 second, the current is defined as 1 ampere. By now, you may have noticed a clear pattern. The SI-based quantities are defined not by physical objects, but by the unchanging constants of nature. All right, that's it for electric current, the 4th SI-based quantity. Now let's move on and see which constant of nature defines the next one. Great job today. Thanks for watching, and I'll see you in the next lesson.